Voyager 1 just sent back a signal from nearly 25 billion kilometers away. And the scientists at JPL who received it say it describes something that shouldn't be there. The data took over 22 hours to arrive, traveling at the speed of light. And when it did, it didn't match a single model anyone had built for what interstellar space is supposed to look like. These are people who have spent their entire careers on this mission, and they were genuinely surprised. So what does a 49-year-old spacecraft, running on roughly 220 watts, barely enough to power the transmitter, with only a few watts of margin left for science instruments, know that we don't? In late 2023, Voyager 1 started talking nonsense. The spacecraft, more than 24 billion kilometers from Earth, began sending back a meaningless, repeating pattern instead of data, and it kept doing so for about 5 months. Not static, not silence. A pattern, which somehow felt worse because the spacecraft was clearly alive and clearly trying. It had simply stopped being able to say anything intelligible. By early 2024, engineers had traced the trouble to the Flight Data Subsystem, one of the spacecraft's 3 onboard computers, the one that gathers and packages information before it is transmitted. A single chip in that computer's memory had failed. A stuck bit had knocked out roughly 3% of the subsystem's memory, and crucially, that memory held part of the software's own code. On Earth, you replace the chip. You open the case, swap the part, reboot. Done in an afternoon. At 24 billion kilometers away, engineers brought it back not by sending anyone to fix it, which is impossible, but by remotely rewriting and relocating pieces of its 46-year-old software around a dead memory chip, with every command they sent taking the better part of the day to arrive. Think about what that actually means. It's like trying to fix a car engine by mailing a handwritten letter to a driver you cannot call and then waiting 2 days to find out if they read it right. And if they didn't, you mail another letter and wait 2 more days. Except the car is hurtling through interstellar space at 60,000 kilometers per hour, and you only get one engine. The chip contains some of the Flight Data Subsystem's code, but simply shifting that code elsewhere wasn't an option. No single location was large enough to hold it. The solution was to break the code into sections, tweak them so they still functioned as a whole, and store them in different places in the FDS. On April 18th, JPL engineers sent a command through the Deep Space Network to relocate the affected section of code to another part of the spacecraft's memory. Roughly 22.5 hours later, the radio signal reached Voyager in interstellar space, and by the following day, it was clear the command had worked. Voyager began returning useful data again on April 20th. Science data from all 4 instruments resumed by June 2024, though by 2026, only 2 instruments, the plasma wave subsystem and the magnetometer, remain operational. The spacecraft was back. And here is where you need to stop for a second, because the thing that was now sending back clean science data was built before the first Star Wars film came out. Its computers were designed in the 1970s. It is running on 23 watts, less than your refrigerator light. Remove or replace with verified claim. For example, its computers were designed in the 1970s and have been running ever since, with engineers working around failures they cannot physically repair. And the JPL team just performed remote microsurgery on it across a distance that light itself takes over 22 hours to cross. That is genuinely one of the most extraordinary feats of engineering in human history. Voyager 1 crossed the heliopause in 2012. The boundary where the sun's solar wind finally runs out of pressure and interstellar space begins. The edge of our solar system's magnetic bubble. What lay ahead was the interstellar medium, the material between the stars, the stuff that fills the galaxy. For over a decade, the spacecraft has been measuring that medium, but the readings coming back from the restored data stream in 2025 and 2026 suggest the space beyond the heliopause behaves in ways that don't match the models scientists spent decades building. The boundary, it turns out, is not a clean line. The question now isn't whether the data is real. The 2024 recovery made sure of that. The question is what the data is actually telling us about where our solar system ends and the rest of the universe begins. The JPL team just rewrote 46-year-old software across 22 hours of signal delay. Do you think that ranks as the greatest feat of remote engineering ever pulled off? Or is something else holding that title for you? Drop your answer in the comments below. Now here's where it gets even stranger, because what Voyager sent back once it was healthy again is the part nobody saw coming. Now the data is clean and confirmed, and what it's actually saying is the part that reorients everything. For decades, scientists modeled the interstellar medium the way you might imagine the space between stars: vast, quiet, and largely uniform. A smooth ocean. Voyager 1 would glide through it, measuring a steady plasma density, and the numbers would confirm what the equations predicted. That was the assumption. The restored data stream, flowing again since mid-2024, is systematically dismantling it. What Voyager's plasma wave system has been detecting is not a smooth ocean. The interstellar medium beyond the heliopause, the boundary where the sun's solar wind finally runs out of pressure and true interstellar space begins, is turbulent in ways the models didn't anticipate. The plasma density fluctuates. It spikes. It hums with what researchers describe as a persistent, narrow-band emission that doesn't behave like anything the textbooks predicted for this region. Think of the old model as a soap bubble. Smooth, round, a clean membrane between our solar system and everything else. What Voyager is now reporting from the other side of that membrane is something closer to crumpled foil, irregular, shifting, and far more dynamic than anyone built their equations around. Jamie Rankin, an astrophysicist at Princeton University and Voyager's deputy project scientist, described the resumption of science data as something her team was both excited and relieved to receive, because even the engineers who nursed the spacecraft back to health weren't certain science data would come back at all. The fact that it did, and that it's coherent, and that it's strange, is a triple surprise. Here is why that strangeness matters beyond the abstract. The models scientists use to describe the interstellar medium are not just academic curiosities. They are the same models used to calculate how much cosmic radiation reaches Earth, how the sun's magnetic bubble shields the inner solar system from galactic particle bombardment, and, critically, what any future probe heading toward another star would actually fly through. If the boundary is more porous and turbulent than the models assumed, every calculation downstream changes. Radiation shielding estimates for crewed deep space missions, trajectory planning for any interstellar precursor probe, our understanding of how the sun itself interacts with the galaxy. All of it sits on top of assumptions that a 48-year-old spacecraft is now actively revising. And the scientists are honest about what they don't yet know. The persistent plasma fluctuations Voyager has been recording since the data stream was restored are still being interpreted. The 2020 anomaly, a sustained jump in both magnetic field intensity and plasma density that Adam Szabo, an astrophysicist at NASA's Goddard Space Flight Center, compared to a piston compressing interstellar material, never returned to baseline the way earlier anomalies had. No one has a fully settled explanation for why. That is not a weakness of the story. That is the story. This is science happening in real time, from an instrument nobody expected to still be functioning, measuring a region of space no other human-made object has ever reached. I want you to sit with that for a second. Voyager 1 was launched in 1977. The people who designed it are mostly gone. The engineers keeping it alive today are working with hardware they cannot touch, software they can barely update, and a power source that loses roughly 4 watts every year, meaning the spacecraft is operating on a budget that will eventually simply run out, likely sometime in the early to mid-2030s. And yet, right now, in 2026, as it approaches the milestone of traveling 1 full light day from Earth, it is still returning data that forces researchers to reopen questions they thought were closed. This isn't just a space story. It never was. It's a story about what happens when you refuse to give up on something that was supposed to be finished 40 years ago, and what the universe hands you in return when you don't. Subscribe if you want more like this, and watch this one next.